Let's move on to one that's a little bit more complicated. And this is one that people get wrong every single time, every single year, because no matter how much we talk about it, we all tend to fall back into the same mistakes and the same bad habits of thinking that have worked for us for a really long time. And the problem that people have here is that they fail to correctly identify where the base and the height of this figure are. As a middle schooler, you would think that the word base simply means bottom. So what a lot of people want to do there is tell me that this rectangle on the bottom of that prism there, that is the base. And going along with that, if they measure that as the base, they think that the height has to run vertically and that 3 centimeters is the height. Now the problem with that thinking gets back to what we talked about with our definition of a prism back here. Remember that in a prism, every prism has congruent and parallel polygons on opposite sides of the figure. Now if we go back to this shape right over here, if you were going to treat this rectangle down here as your base, there would need to be a congruent and parallel rectangle up here on the top of that figure, and there's not. So this is the wrong way to approach this figure. That is not the way that this thing works out. So what we should be looking for then are two sides on opposite ends of this solid right here that are congruent and parallel to one another. And to do that, we're going to recognize that we have ourselves a triangle right here, and then another congruent and parallel triangle on the opposite sides of the figure. So those two triangles right there, which I'm highlighting in yellow, those are going to be our bases. And the height then is measured as the distance in between those two bases, and that's where your height is. So before you get started at all trying to figure out the surface area of a prism, you really have to spend some time identifying it properly and knowing where the bases are. All right, so now that we know it's a prism, we can use our formula here that surface area of a prism is 2 times capital B plus capital P times H. The capital B means area of the base, the capital P means perimeter of the base. And we've got a little bit of work to do on this one. All right, so let's get started here. So surface area is going to equal a 2 times, and we need to know capital B, the area of our bases. Now our area right here is going to come from this right triangle, and our formula, this can get a little confusing now, is that area of a triangle is equal to a 1/2 little base times height. All right, and to do that, we're going to need to know this dimension right over here to come up with the base of that triangle. Well, this is a right triangle right here, everybody, which means that the Pythagorean theorem is going to tell us this missing side over here. Although this is one I was hoping you guys would recognize pretty quickly. With a leg of 3 and a hypotenuse of 5, when you do the Pythagorean theorem, you're going to find that this piece over here has a length of 4 centimeters. So the area of that triangle is going to be 1/2 times a base of 4, and the height measured perpendicular to that base here on the bottom is going to be 3. So be careful with what I'm saying here, guys. 3 is the height of the triangle. It is not the height of the entire prism. So finishing this up, the area of that triangle, 1/2 of 4 is 2, times 3 is 6. Okay. So the area of one of your triangular bases is going to be 6, and we're multiplying centimeters times centimeters to get square centimeters. You don't need to include that. And then keep going. Plus, capital P means perimeter of the base. So to do that, we're going to add together 3 plus 4 plus 5, and that's going to get us a total of 12 centimeters for the perimeter of that. And the last thing we're missing right here, guys, is the height of the entire prism. So the height is the distance between the bases, which is parallel to this 10 right over here. So 10 centimeters is going to go right there for the height. And again, you could put all of this into your calculator in one step if you wanted. I'm going to go ahead and go step by step. The 2 times the 6 square centimeters is 12 square centimeters. That's the area of the two triangles put together. Plus, you've got 3 rectangles now in the middle of this figure that connect those two triangles. So we multiply the 12 centimeters times the 10 centimeters to get a 120 square centimeter area for those 3 rectangles put together. So the 2 triangles on the end plus the 3 triangles in the middle are going to get us a total surface area for all 5 faces right here of 132 square centimeters for the surface area of this triangular prism. And the last one we're going to do scares people a lot when they see it at first. We've got this staircase. I said we were going to come back to it a little bit later. And a lot of people want to look at this and say, wait a minute, that doesn't really look like a prism. And I can see the argument for it. But what we need to remember is that while we have this goofy shape here, the staircase, over on the left-hand side looking like that, there is a congruent and parallel staircase over here on the other side of that figure. And because this solid has congruent and parallel polygon bases on opposite sides of the figure, it is in fact a prism. So our formula is still going to stay the same, even though this one looks more complicated. Surface area is 2 times the area of the base plus the perimeter of the base times the height. And right away we run into some trouble on this one. 2 times, and the area of the base is going to be challenging because our bases are these 2 figures right here on the left and right hand sides of this figure, so we're going to have to come up with the area of just that shape. So let me try to redraw it over here on this side without taking up too much space. All right, it looks something like that. I see a 12 over here on the left, and I see a 12 down here on the bottom. And then it looks like every one of these pieces here was 4 inches. 4, 4, 4. So I think we're just going 4, 4, and 4, and 4, and 4, and 4, somewhere right there. Sorry guys, kind of tough to draw. So we got to try to figure out what's going on with this particular figure right over here. So to come up with the area of that base, which I'm going to call capital B, I might divide this one vertically like that. All right, so the first shape right over here is a rectangle with a base of 4 and a height of 12. So the 4 times 12 is going to get us 48 for the area of that rectangle. The second part of that figure, rectangle 2, it's another rectangle, again with a base of 4, but this one is 4 units less in terms of its height than rectangle 1 was. So since that was a 12, this height is going to be 8. So 4 times 8 is going to get us 32 for the area of that second rectangle. And for the third rectangle right there, looks like we just have a 4 by 4 square, and that's going to be 16 for the area of that third rectangle. So let's add all of those together, and we should end up then with a total of 96, if I'm not mistaken. Yeah, and that would be 96 square inches for the area of one of those yellow bases. So I'll just go ahead and put a 96 here. I think at this point I'll leave the units out for now. Plus, all right, more fun here with that goofy shape. We need to come up with the perimeter of that base. So to do that, we're just going to be adding together the side lengths in that figure. So let's do it as we go along here. We've got a 12. There we go. We've got a 12 and a 12. We're at 24. Now I think we have a whole bunch of 4s. Let's count them along. We've got 1, 2, 3, 4, 5, 6 4s. So the 12 and the 12 are going to get us 24. And we're going to add to that the 6 4s that we just came up with on the staircase, which is also going to be a 24. So the perimeter of that figure is going to be 48 inches. All right, that took care of the 2 hard parts. The last thing we have to worry about is the height of that figure. And let's remember, everybody, height does not always mean up and down. Height means distance between the 2 bases. And since the bases are on the left and the right, the height here runs in this direction. That 8-inch measurement right there is going to be our height. All right, so let's put all this together now, guys. Again, you could do this all in your calculator in one step, and this one I'm going to cheat and do with you here. So a 2 times a 96 plus a 48 times 8 is going to get us 576. Every distance here was measured in inches, so since we're talking about a surface area, that's going to be 576 square inches for the surface area of that figure. Okay, guys, it's a tough section. Let's do the best we can with it. We'll come back tomorrow and we'll do surface area of cylinders, which is actually going to be a lot easier than what we did today.